about yesterday's learnings. Let us
I think
clarify.
SciPoc needs to be explained bit more in detail.
Somebody explained the SciPoc yesterday.
The SciPoc was not explained in detail. I think we gone
Yeah.
through the
That will be
Pareto
explained next
analysis.
week. Next week only the SciPoc, we will be dealing. So wait for it. It will be discussed in detail.
Sir, yesterday's final RK sir session I missed. I will watch the recordings tomorrow, sir.
Yes, definitely. You have to recordings.
Sure. Yes.
Yes, and his topic was to give you an overview of defined phase and then help you understand how you can make use uh, Pareto to prioritize your problem, right? How you can make use Pareto to prioritize your problem. Do you think prioritization is important?
Yes, sir.
Because you have to always, if you have a chain of so many linkages, and if one particular link is so weaker, then which link you must strengthen first? The weakest one or the other strongest one?
The weakest.
Weakest one.
The weakest one. Because if you don't understand this logic, if you work on the other links, leaving the weakest one, your efforts are not going to make any difference. Again, the same chain, will break into pieces. So what's very, very important is, you must understand the exact constraint, which is actually, pulling our result. And once the constraint is understood, then you must modify your system in a way that the capability of the constraint is enhanced. That's how you can impact the overall capability. So merely working on a project, sometimes may not be helpful to the organization, and you need to find out which is the constraint, and then you must act on the constraint. And once you fix the particular constraint, then the next weakest link will become the next constraint. Because it is always, your overall capability, your performance is decided by the weakest link in the chain, right? So that's how it is. So in that sense, yes, Pareto helped. And what are the other things you learned? Each one of you, could you please point out one important learning, not just in a single line? And all of you, you can come on video, right, and make it as a practice. And again, I'm telling you, this is one of the best practice. If you are not adopting best practices, then there is no point of becoming a belt and then becoming a lean practitioner and things like that. If you know something is the best practice, you must put it into practice. Not only here in the session, but also in your personal life, but also in your professional life. After knowing something is good and you still don't adopt it, and that is what the big problem nowadays. And then you have to learn, you have to master another big area known as change management. Someone has to sit next to you to motivate you to take the action. No, that should not be the case. And the next agenda is, each one of you, could you please tell one, you were learning yesterday in one line. What is that you learned yesterday? Anything that that you learned that added into your knowledge? Just one point. All of you, each one of you should tell one point so that I can.
Efficiency and effectiveness.
Efficiency
Yesterday,
and effectiveness we discussed. So what is your understanding now?
yesterday we learnt one thing. RK sir told about the means Pareto analysis by 80/20 rule method.
Very good. This way of statement I like. Pareto analysis 80/20. Pareto analysis means 80/20. That means 80% of the complaints are coming because of only 20% of the defects which are considered critical. All others are trivial in front of these critical issues. Or 80% of the cost of poor quality are contributed by just 20% of the defects. That is a good learning. Okay. And effectiveness and efficiency. Is there a difference between the two?
Yes, sir. Lean focuses on
Effectiveness.
effectiveness and Six Sigma focus on efficiency.
No, you have just interchanged. Lean focuses on efficiency and Six Sigma focuses on effectiveness. Effectiveness means defect free. Efficiency means waste free. Right? Effectiveness means defect free. Efficiency means waste free. But please note, your effectiveness should not happen at the expense of efficiency. And your efficiency should not happen at the expense of effectiveness. Without losing the other, you must improve the other.
Yep.
Right? And that's how, Lean and Six Sigma works. Just because you wanted to improve the effectiveness, you should not lose all your efficiency. So retain the current efficiency and improve on the effectiveness. This is Six Sigma project. Retain the effectiveness and improve on the efficiency. This is a lean project, right? The primary focus is changing. And what is the principle behind Six Sigma? How Six Sigma reduces and prevents the defects? By
Process improvement.
reducing variation.
Defect variation.
Variation.
Reducing
Defects
variation, right?
and
That
variation.
word should come in your mouth, and you should be so much comfortable talking about variation.
One of the
And,
example you covered about the orange and apple also, y is equal to fx, where if you see means if you want to produce something else, you need to produce that same. Now you cannot grow apple trees. You cannot find apple fruit in orange. So you need to
Correct.
produce that specific kind of work process in order to get that desirable result.
Definitely. There is a lot of learnings from that particular slide. I do not know how many of you understood, even though it just looked like one slide that has covered the whole course. I've taken you up to the analysis part, right? So apple tree cannot give, or orange tree cannot give apples. That means you should always think about the built-in quality. Whatever the quality you have built in a process, that much only it can deliver. Only that you can expect. Anything more than that definitely requires a detail, attention to details. Got it? Right? So anything more than the design quality requires revisiting the process, and you must get into the details, and probably you may have to re-engineer your complete process. Right? But if there is a problem in achieving the built-in quality itself, then definitely the existing process can just be improved, and then results can be done. So change management is one thing. You should not be so resistant to change. Then you will continue producing oranges only. You will never be able to produce apple, right? So change management. At the same time, the process thinking, right? And the built-in quality, idea of built-in quality. And then the problem-solving approach, y equal to f of x, right? Y depends on x. And when you want to fix any problem with respect to y, you must first of all, talk about the y in specific terms, not in a broader term. If anything you are taking, in a broader sense, you will keep on talking. You will never be able to take action. So you have to drill it down. You have to make it very, very specific. And if you make it very specific, it becomes measurable. You have to drill down to the extent that it becomes measurable, and then it also becomes actionable. What cannot be measured cannot be improved. You keep on talking only, right? So once you identify one such metric, or several such metric, then each of them will be considered CTQ. These are nothing but the technical versions of your voice of the customer. You can't expect your customer to be engineer or a doctor or a chemist or a pharmacist to talk in terms of your language. It is your job. He can always talk only in terms of his language, and you have to convert that into the technical terms. All of them we call it as CTQ, critical to quality characteristics, right? So earlier we were talking about the defects, variation. Defects comes from variation, and which side of the equation will lead to defect? If the variation at the output is higher,
Input.
Input.
yeah, of course, input is the cost, but what the customer will experience? Customer will experience the output.
Output.
But who is controlling the input?
X
We are controlling the
We are
input. I mean, we are controlling the input, right?
function X.
So we have to be operationally correct. We have to develop good habits, right? And what we have been repeatedly doing every single day are known as our habits, right? This is what we are, in other words, in industries, we call it as operations. We should be operationally correct. We should know the X, which are influencing our Y. Y, obviously, customer looks at it, all the Y's very seriously. And so you must look at all the X very seriously. No other, no compromise over there. If you compromise on the X, automatically you have to compromise on your Y also. And so you have to compromise on the customer satisfaction, and which is definitely not good for a long term, right? So variations in Y needs to be quantified. If it is under control, as a manager, you can understand your operations are in a perfect shape. If the variations in Y are higher, then immediately you must realize no, operationally something wrong is happening. Can you see that, all of you? Yes or no? So your job as a manager is, to look at the data. If you are very poor at, monitoring, yesterday somebody asked you, sir, how can I monitor? You can monitor just standing in front of everything and all the time, like a god. Or you can always, collect the data about important characteristics. Which is easier? Do you want to become God and stand everywhere? Not possible.
Data collection.
But what you can do is, you can collect the critical information about critical characteristics. Data has to come to a table. You make arrangements to ensure the important characteristics are always monitored by way of collecting data. Either you or someone must be assigned to do that job as part of their daily routine. Clear? The machine setting has to be monitored. Cutting tool angle has to be monitored. All right. The lubrication level has to be monitored. So all of them are, really, important. And particularly, initially you must start with monitoring the why, and then gradually understand which are all the X factors which can influence your why. And some of the X factors already you might have a very good control. Some of the X factor already you might have very good control. But other X factors, if you have poor control, you must bring it under monitoring. And then, and then look at the data. In what range that particular X is varying. If the X is allowed to vary in that particular range, is it safe for your Y? You get my point? A particular X is currently varying by a huge margin. Let it vary, no problem. As long as it is not affecting my Y, I don't want to control that X. Yes or no? But in the current operating range of the X is harmful to the Y, then what should you do? You should reduce the operating range. Yes or no? Yes or no? You are not
Yes,
able to
yes,
understand
yes.
this.
Yes,
Yeah.
yes.
Yes.
So you have to reduce the operating range. Sometimes you may have to change the operating range. The range has to be completely a new range. Yes or no?
Yes, sir.
Yes.
You may have to move the X, onto the right side. Sometimes you may have to move the X to the left side. Maybe temperature has to be increased sometimes. Temperature has to be decreased sometimes. The operating range of the temperature has to be, made minimal sometimes. These are all nothing but the actions which will become part of your solution. The important part of your solution. So in order to make this decision, whether X must be moved to the right side or moved to the left side, or the operating range of the X has to be reduced, you must study the relationship of the X with respect to the Y. You must study the relationship. Like sugar and sweetness are positively related. I put more sugar, I get more sweetness. Yes or no? I eat more, I gain more weight. Can you see positive relationship in all these examples? Similarly, there can be negative relationship also. If I do more exercise, what will happen to my body weight? It may come down. Right? And similarly, sometimes what happens if you drive a car at a higher speed beyond the optimal, then that interval can pull down your mileage. Negative relationship. Right? So positive relationship is also possible, negative relationship is also possible, dynamic behavior is also possible. Dynamic behavior means up to certain speed, it is good for your mileage. But beyond that particular speed, the same speed which helped you so far can become harmful. Yes or no?
Yes.
So me giving you a lot of theory may be interesting and then useful for you 9:30 to 10:30, 11:30, 12 o'clock. But afterwards, the same thing, will become troublesome. So that this relationship can change for your X also. The relationship remaining positive can suddenly change and then it can become negative. This is what is known as dynamic relationship or nonlinear relationship. Dynamic relationship or nonlinear relationship. If the relationship, remains constant, at the same time, the effect also uniform. The effect produced by the X, if it is uniform, the relationship is not only stable, it is known as linear. You get my point? If the effect is stable, right? I mean, the effect is, always, stable and over and above, the amount of impact is also no a constant impact. Then it is known as linear. If the behavior is dynamic and the effect keeps on changing, at certain range the effect is more, at some other range the effect is less. This is what is mathematically known as non-linear relationship. You must try to understand all of this. That means you are transforming yourself into an expert. Isn't an expert will only know all of this, yes or no? If you
Yes,
call
sir.
an external
Yes.
expert and he will come and say, sir, this is the critical factor. And my point is, why don't you identify the critical factor yourself? All that you need to do is, spend some quality time, conduct some experiment and look at the data. If I keep on changing the X, what happens to my Y? Is my Y also changing? That means X is influencing my Y. Clear, isn't it? It is not just happening in one experiment. When I repeat the experiment, the same result only I'm getting. Every time I increase the X, I see an increase in Y. Can you not understand? Your X is influencing Y now, isn't it? So this is the purpose of conducting experiment, and the particular tool is known as design of experiment, which we will be talking only in the third week. How to conduct an experiment in a way that you understand the pure relationship between X and Y, because you should not give any room for the error to dominate. So, and then after that, we should also try to understand the sufficiency. Sufficiency in the sense, how many X factors are currently, currently influencing my Y. How many X factors are currently influencing my Y? How many X factors have a higher operating range? How many X factors are operating in a wrong range? Do you get my question? If there is only one root cause which is pulling your result, you just have to take one action. If there are multiple root causes, you may have to take multiple actions. It is like, having a pot with multiple holes. And now to retain the water, you have to close all the holes, yes or no? Just by closing one hole which you have seen, will you be able to retain the water? No. So this is known as sufficiency. And identifying the relationship, understanding the sufficiency, you will be able to make yourself comfortable only if you master a tool known as regression analysis and DOE. Till the time you become comfortable with the design of experiments and regression analysis, you cannot be comfortable hearing the terms like relationship, hearing the terms like how many root causes. If somebody is asking you how many root causes, then you have to fumble. If somebody is asking you what will be the solution, what are you supposed to do, and then you will definitely lag in terms of the confidence. But to gain confidence in that area, you must definitely master two important tools. What are the tools I told you? Design
Regression
of
analysis and
Design of
sufficiency.
experiments
design
and
of
regression
experiments and then regression analysis.
analysis.
These are statistical tools, right? Analytical tools. But then if you follow us, in a proper way, right? Day 1, day 2, day 3, day 4, and day 5, day 6 can be phenomenal transformation, right? So this is what we actually spoke yesterday. And then RK would have talked to you, about a defined phase. In defined phase, what is our goal? Our goal is to define the problem properly. Because a problem well defined is half done. A problem, if the problem is not understood properly, then you are not fit to handle that problem. Yes or no? Isn't it? First thing is, you must first, you must seek first to understand. Then you expect, others to listen to you. If you don't put efforts to understand the problem, and then you straight away you talk about the root cause, straight away you talk about the solution, and nobody will pay attention to you. So that's why defined phase is introduced by General Electric, not by Motorola. When Motorola introduced Six Sigma, it only had 4 stages: measure, analyze, improve, and control. General Electric only pointed out this gap and then converted the Mac into DMAC. They did it in the year 1995. So define means you gain a detailed understanding of the problem. You are considered to have gained a detailed understanding of the problem if you convert the problem into a specific problem. The boundaries of the problem must be understood. The boundaries of the problem must be understood, right? So what is the boundary within which, I have to fix the issues. Right? There can be hundreds of defects that are happening. Do you want to fix all hundreds of defects in one go?
No.
Definitely no.
Not possible.
You can't chase multiple rabbits at a time, right? Just chase one. Solve problems one at a time. So what is the defect you want to attack? Within the defect also, are there any categorization available? You have to check for it. Within that defect, if there is any categorization, and you have to choose which category, can be apt for you. You can't simply, try to fix everything. And once this is called, problem understanding. The scope is made very clear. My company has factories in 10 locations, but I want to run a project only in the Bangalore location. I very well know the same problem exists in other factories also, but I am not going to bring everything in the scope of my project, because if I know if I bring everything in the scope of my project, I will fail miserably. Yes or no?
Yes.
I cannot make a progress. So I will limit my scope only to Bangalore. And within Bangalore, there are so many products are getting produced. I know defects are happening in all the products. I am not going to take everything. I'll choose only one specific product which is critical in the current time. And that particular product, there can be multiple defects. Out of the multiple defect, I will choose one. Because there are enough number of people available in the organization who can also work similar to you. Yes or no?
Yes.
So everyone is responsible. There are hundreds and thousands of problems. Only thing is, they don't have an eye to understand the problem. Many people don't recognize the problem. There can be defects happening right in front of their table. There can be waste happening right in front of their table. But the only thing is they don't recognize that, a defect is happening. They don't recognize, the waste is happening. So, but by going through these kind of trainings, and then knowing these kind of approaches and tools and techniques, you will get a third eye using which all the problems, will get visualized. That is the only difference. All right. And then you consider one specific problem, and now try to find out a metric. Try to find out a metric. If I communicate about that metric, my boss must be able to understand. My customer must be able to understand. Most importantly, I should make my customer understand. So accordingly, I will choose one metric. Say for example, you purchased a car, and then the fuel consumption is so high. Customer is very unhappy. Now, what is the metric you will convey him? You will talk to him about. You will talk to the customer about the mileage, isn't it?
Yeah.
The mileage is the metric which my customer is unhappy with. But the mileage is, CTQ, critical to quality for my customer. But mileage, can improve only if I optimize the combustion process, the fuel burning process. Yes or no?
Yes.
How the fuel is burnt inside the cylinder is finally responsible for the mileage. But my customer may not understand, whether fuel is burning inside or not. Right? So one side is critical to quality. Other side is some internal metrics. Some internal metrics, isn't it? So those internal metrics will definitely have a direct relationship with your CTQs. Yes or no? So these internal metrics are sometimes we call them as critical to business. Critical to business. So we try to find out the CTQ as well as CTB, and then one out of the two we will take it as our project metric, pain metric, right? Then if I say mileage, you need to understand whether it is a capital Y or a small y. Yesterday I spoke about capital Y and small y. If I talk about the taste of the coffee, it is capital Y or small y? Taste of the coffee.
Capital.
Capital Y.
Y. Because taste has many meaning inside. It should be sweeter, it should be stronger, it should be hotter. The combination is what is giving you the taste. So you have to find out the smaller y. Y1, Y2, Y3. And that specific Y which you want to improve through your project is known as CTQ. If you talk in terms of the CTQ and identify the CTQ, problem is considered to have defined. If you are not good at identifying the CTQ, even though you try to do a project and work on a project, still you may not be able to achieve the result. So define means you identify a single metric which is actually responsible for the customer dissatisfaction. Is that clear to all of you? You identify a single metric which is responsible for the customer dissatisfaction, right? So, and your whole project is now built around that particular metric. This is known as pain metric. And now you have to create a project execution plan. You have to create a project execution plan. The project execution plan is known as the document carrying the project execution plan is known as project charter. A document carrying the project execution plan is known as project charter. And that project charter we are going to discuss today as the first topic. Clear, all of you? And then we move on to measure phase. Okay.